Well, hello everybody. Let's come straight away to the point. We have been talking about the concept of the source and sink, right? Concept of source and sink, as well as the second law of thermodynamics, right? I hope that you might have seen my video on this one, right? So we'll be continuing with the same, and I will explain you the practical application of the second law of the thermodynamics and what is the physical significance of the source and the sink. Yeah, so we have seen that there are the three types of devices. The one is heat engine, second one is heat pump, and the third one is your refrigerator. Yes, which is kept in your house. You can see out there in your house, right? Refrigerator. Okay, so I will be explaining you all what is the principle of these three devices. Okay, fine. So now let us first come to the heat engine. Just don't understand what happening to it. Okay, fine. So let us first come to the heat engine. If we talk about the heat engine, right? And if we talk about the second law of thermodynamics, what it says in your Kelvin Planck statement, that it says that there is no engine that could transfer the whole heat and converts it into the work. Not at all. It is impossible for it, right? So what it will do? It will take away the heat from the source. Okay, done. We'll do some work and we'll dump the rest of the heat to the sink. Yeah. Okay, so now this will be right. It will be following the Kelvin Planck statement of the second law of the thermodynamics. Yeah, fine, perfect. So now we see that how it will work. Suppose once more this is the source, which is maintained at temperature T1. This is the sink, which is maintained at the temperature T2, and we know that T1 is more than T2 because the temperature of the source will be more than the temperature of the sink, right? And here is your heat engine, HE. Yeah. So from here the heat will be extracted out, Q1. It will do some work on the way, W, and it will dump the rest of the heat, or will send the rest of the heat, Q2, to the sink. Okay, fine. One thing you should keep in your mind, that that the heat interaction with the source, the heat interaction with the source, the heat interaction with the source, with the source is Q1. Okay, and the heat interaction with the sink is Q2. What it means heat heat interaction means what? Whether you are going to extract the heat or you are going to send the heat, it does not matter at all. What it matters is that you have to write it always Q1. You have to write it always Q1. Okay, fine. So the heat interaction with the source is the Q1, and the heat interaction with the sink is the Q2. Fine. Okay, next. Now if you see this diagram, we form an equation like this one, that Q1 is equal to W plus Q2, right? I hope that you can see it. Okay, fine. So we can say that W is equal to Q1 minus Q2. Fine. Now if you are told to find out the efficiency of the heat engine, in that case the efficiency of the heat engine will be the work done upon how much heat you have extracted from the sink. Okay, the heat extracted from the sink, extracted from sink. Okay, fine. So what is the efficiency of the heat engine is that W by Q1. Are you satisfied with this? W by Q1. Okay, fine. So now if we see out here, if we rewrite this equation, it will be coming like this: Q1 minus Q2 by Q1 will be the efficiency, and if you are going to modify it, 1 upon Q1, sorry, Q1 1 minus Q2 by Q1. Okay, fine. So in the numericals, if you have the values of all these things, then you can find the value of the efficiency of the heat engine, right? If suppose in your numerical problem you are having the value of the temperatures, yeah, the source and the sink one. Say if we have the value out here T1, if we have the value out here T2, and here you have the heat engine, right? And it does some work W on the way, okay, and we have not been given the values of the Q1 and the Q2. We don't have the values of the heat interactions with the source in the sink. In that case, we can write the efficiency of the heat engine as T1 minus T2 by T1, yeah, and hence it will be your 1 minus T2 by T1. Okay, fine, you can directly solve your numericals based on the same. Fine, okay, now we come to the heat pump. Now we come to the heat pump. Okay, what is heat pump? See, if we stress upon the word pump, it means what? That we have to throw something opposite to its nature. Means what? Suppose if we have got the water out here at the very lower level, and we have to throw this water at the higher level, right? Right? If the water would have to flow from the higher to lower, it will come down spontaneously. We don't have to do any work on that. Okay, it will flow down, right? But what if we want that the water should flow from the higher to the lower, sorry, from lower to the higher level, right? For that case we have to use one device. We have to do some work. So that work is known as the pumping work, okay, and this device is known as the heat pump, and this device is known as the heat pump, right? Means we have to pump the liquid, the water, from the lower to the higher level, which is against the nature of its flow. The nature of the flow of the liquid, of the water, is from the higher to the lower, but we have to send it from the lower to the higher level, and for that thing we have to use the pump, right? So here if we use the term heat pump, is what? We have to pump the heat. Acha, we have to pump the heat. Why so? Because if you see there out here, if we have a body at a very high temperature and we have a body at a very lower temperature, right? The heat will spontaneous flow from the higher to the lower. Yeah, it will flow like that. We don't have to put any work on that. We don't have to put any effort on that, right? It will flow spontaneously, अपने आप से ये बह जाएगा. But suppose if we want to make the heat flow from the lower to the higher one, here ऐसे 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 ऐसे, so for that case we have to use the pump, the heat pump, so that it can transfer the heat from the lower temperature to the higher temperature. Okay, fine. Okay, nice. So now let us see the diagram of the heat pump. It will be following as thus. Here it is your source T1, and here it is your sink T2. The body which is at the lower temperature is the sink, and the body which is at a higher temperature is the source. Okay, so we are going to transfer the heat from the sink to the source, and I have told you that the heat interaction with the sink will be your Q2 and the heat interaction with the source will be your Q1, right? It can't be done like that. We have to do some work on this. Do you remember one statement of the second law of the thermodynamics? That is the Clausius statement. Clausius statement. What does it say? It says that without the aid of any external work, we cannot transfer the heat from the lower temperature body to the higher temperature body. Okay, fine. So we have to do some work on this one. So it will be following the second law of the thermodynamics. Okay, fine. So now if you are told to write the equation for this one, we used to find out the coefficient of performance. या ठीक है, राइट? एक मिनट, मैं करता क्या हूं, आपको एक काम करता हूं. आई शुड ऑल्सो एक्सप्लेन यू द रेफ्रिजरेटर वन ऑल्सो, ठीक है, एंड देन आई विल एक्सप्लेन यू द बोथ. एक साथ मैं आपको बताऊंगा. इफ यू सी द रेफ्रिजरेटर, यहां भी क्या होता है आपका, वी हैव टू ट्रांसफर द हीट फ्रॉम द लोअर टू द हायर. हाउ? सी, ये आपका फ्रिज है, फ्रिज, राइट, एंड दिस इज योर रूम. Fine, this is your room, and this is your fridge, and this is your fridge. Okay, we know that temperature of the room is the T1 and the temperature of the fridge inside the fridge it is the T2, right? So T1 will be more than T2, right? In that case, as per the law of the thermodynamics, we know that if anything which is at a higher temperature is known as the source, so our room has become the source. If anything which is at the lower temperature will be the sink, so our fridge is the sink. ठीक है, ये सोर्स हो गया और ये आपका सिंक हो गया. Fine. Okay, so now what we have to do, we have to make the fridge cooler, and for that case we have to extract the heat from the refrigerator and send in the room, right? तो हमें इसमें रूम में इसको भेजना होगा. तो मतलब if we see the flow diagram like this one, this is our room which is actually the source, okay, which is maintained at the temperature T1, and this is the fridge, okay, which is the sink, and it is maintained at the temperature T2, ठीक है, and this is the heat pump or compressor, ठीक है, of the refrigerator, ठीक है. तो ये आपका हो गया Q2, ये आपका हो गया Q1 हो गया, ठीक है, और इसके ऊपर आपने कर रहे हो वर्क W, ठीक है ना. Now if we see that how the work it will be done, see, oh sorry, how you will write the equation for the same, so it will be your uh, Q1 is equal to again W plus Q2, and if you have to find out the work, that will be your Q1 minus Q2, ठीक है. Fine. Okay, so now we will see both the diagrams of the heat pump and the refrigerator together. See, this is my heat pump, source, sink, we have to do some work, Q2, Q1, and this is our refrigerator, source, sink, work done, heat extracted out, heat dumped out, right? See, this is the heat pump and this is the refrigerator. So now what is the difference? Okay, in both the things we have to find out the COP. Yeah, we have to find out the COP. COP. What is the full form of the COP? Is the coefficient of performance. Coefficient of performance. ये क्या होता है? क्या होता है? This is actually the desired work output. Desired output by work done. Okay, how much work we have done and what is your output. Okay, fine. So now how will we find out the desired output in the heat pump, and what is the output that you desire in the refrigerator. Okay, ठीक है. We expect that in the heat pump how much more heat can be transfer out to the source. Okay, means we have to stress upon the Q1, and here how much heat you can extract from the sink. जितना ज्यादा आप हीट निकाल पाएंगे फ्रिज से उतना आपका फ्रिज ठंडा रहेगा, राइट? तो दैट इज योर Q2, ठीक है, फाइन. So now if you see that COP in the case of the heat pump that is equal to Q1 by W, and COP in the case of the refrigerator is Q2 by W. Perfect. And if we see it more, the COP of the heat pump is your Q1 by Q1 minus Q2. Okay, and COP of the refrigerator is the Q2 upon Q1 minus Q2. Okay, fine. Why? Because I have just replaced the value for this W out here. See, it will be same value. Okay. Okay, now if we rewrite it out and find out the relation between the COP of heat pump and the COP of R, relation between COP of heat pump and COP of R, then what it gives? COP of heat pump, suppose if you add 1 in this, we get what? Q2 upon Q1 minus Q2 plus 1, that is equal to Q2 plus Q1 minus Q2 upon Q1 minus Q2. Here we get it is your Q1 upon Q1 minus Q2. Q1 upon Q1 minus Q2. So we get that COP of the R plus 1 will give you the COP of the heat pump. Yes, this is actually what? This is actually the COP of the heat pump. So we can say that the COP of R plus 1 is equal to the COP of the heat pump. Okay, it was all about the base of the heat pump, heat engine and the refrigerator, and we have to put the values, we have to see the nature of the numerical, and we can find our respective answers for that. So all the best for the numericals on the same. In the following sequel of this video, I will be solving the numerical on the same. Thanks for watching my video.